So this video is going to talk about more equations and specifically a way to better write an equation. So let's pretend we have a little scenario here where you have a bank account and you have a relative that deposits $40 each month into the account for you. After 11 months, you have to notice that there's $565 in the account. And what you'd like to do is you'd like to write an equation that's going to represent the value of the account. And we're going to call that variable V for value after M number of months. So M is going to be another variable in there. M is going to represent the number of months. That will be our input. And then the value of the account will be the output. So let's think about what we know here. Well, we're told that you're going to get $40 per month. So that word per starts telling me that that's going to be the rate. So that's our slope, our rate, $40 every month. But notice what we're not given a starting value. Instead, we're told after 11 months, you're going to have $565 in that account. So you're not given a starting value, which means, do you want to count backwards 10 months, 9 months, 8 months to try to find that starting value? I know I don't want to do that. No way. So let me show you another way, a more efficient way to determine that equation that we're looking for. So this equation is called the point-slope form of an equation. So similar to like other equations that you've seen, the x is the input, the y is the output. M represents slope, that's our standard variable for slope. But this time we have a point, a data point. We're going to call those data values h and k, where h is the x value of the data point and k is the y value of the data point. So if we're given a point that we know and its slope, we can write the equation using, surprise, point-slope form of a line. So let's think about what we know. From before, we knew that our slope was 40. We made $40 per month. And we also knew that after 11 months, we would have $565. I'm going to write that as a point that may appear in a graph. And so at 11 months, $565. That's a data point. So now we just need to plug those values in to write that equation. So our output was our value. So instead of using y, I'm going to use the value v, or the variable v. Next comes our slope, which is 40. And then in parentheses, I have my x value, which in this case is the number of months. And I subtract from that the value h of my data point. And then we're going to add our 565 on the end. So one thing to notice here is that this thing in parentheses is x subtract the value of h. It's not really a minus sign. We're actually now using it as a subtraction, an operation. And I'll show you why that's important later on. So this equation that we wrote, v equals 40 times the quantity m minus 11 plus 565, that represents the value after any number of months. And let's check it out for a minute. Let's suppose we want to figure out how much after 12 months. Well, I'm picking 12 because I know you're just going to have to add $40 more to it. So when I plug in 12 for m, see what happens. I get 40 times 12 minus 11 plus 565. 12 minus 11 is 1. So I have one additional month at $40. And that will determine what our value is. So let's take a look at another scenario. Have you ever been to some of these indoor trampoline facilities? This one's hosting a birthday party. If you can bring 12 people, they charge you $150. That's like their flat fee. But then if you want to bring additional people, it costs $8 per person more. So in this scenario, first identify the point and the slope. So the point is going to be like a combination of number of people and a cost. So my point is going to be 12, 150. 12 people cost $150. my slope is going to be 8 because it's $8 more per person. So now let's write the equation. We want the cost C of having P people. So that means my variable is going to be C equals. It's not going to be Y equals. It's going to be C equals. I use my point slope form. I put my slope next. In parentheses, P subtract the H value of my data point, the X value of my data point. So P subtract 12. My 150 is positive, so I put a 150 on the outside. This equation can be used to determine if you're bringing more than 12 people, how much it's going to cost. So check out the family that was charged $222 for a birthday party. How many people attended? Well, this $222 is a cost, and I'm looking for the number of people. I want to solve for C. So I'm going to plug 222 in for my value C, and I'm going to solve that equation. So take a minute, see if you can solve it. So the first thing I'm going to do is I'm going to undo it by subtracting 150. And that gives me 72. Next, I'll divide both sides by 8. 72 divided by 8 is 9. Let's keep undoing. Add 12. P is 21. So how many people went to this party? 21 people did. Hope they had fun. Now, what's really neat about this point slope is it doesn't always have to work in a context. It can work just on a regular equation that we might write. If there's no story behind it, we can still write the equation of the line. So we're going to write it with slope equals 2/3, passing through the point -1, 5. Ooh, watch what's going to happen here. So first of all, I don't need a context, so I can use X and Y. Here's my slope. Now, check this out. I want to take a second and write this. It's X subtract the H value, the X value of my data point. So it's going to be X subtract -1. So notice how I use the parentheses to show that I'm subtracting -1. My K value is positive, so I'll write +5. But we can clean this up a little bit because you might remember doing keep change change for that thing in parentheses. So now we'll get Y equals 2/3. And in parentheses, let's write X plus 1. And then add 5. So notice when we subtract that negative, it becomes a positive. Now, continuing along, our second one, notice that we have 2 points here. We don't have a point and a slope. But 2 points will allow us to find the slope. So remember, your slope is the change in Y over change in X. So if I look at my Y values, I'm going from -2 to 4. So I'm going to do -2 subtract 4, change in Y over the change in X, 5 minus 3. So I get -6 over 2, which is -3. So my slope is -3. Well, now I've got 2 points, and it doesn't matter which one we choose. So one equation could be Y equals the slope times X subtract 5. I'll use my first point. Notice now that the Y value of the point is negative, so I'll bring down a -2. Or if I use my other point, X minus 3 plus 4. Either equation is correct. Doesn't matter which one you use. Now let's take a minute and graph one of these equations. And I'll graph the first one that I wrote. I'm going to graph Y equals -3 times X subtract 5 subtract 2. So first, let me go plot that point. I'm going to go plot the point 5, -2. And through this line, or through this point, a line has a slope of -3. So I go down 3 into the right 1, down 3, right 1. I'm going to erase those little dots there. I don't need those. If I'm going the other direction, let's go up 3 and left 1, up 3 and left 1, up 3 and left 1. Up 3, left 1. And there's our line. Now notice a couple things. Yes, I know it went through the point 5, negative 2. Do you remember the other point that we had to go through? It was the point 3, 4. Well, it did. It went through the point 3, 4 as well. So hopefully what you recognize here is that the point-slope form of a line is a very, very efficient way to write the equation of a line. It's one of my favorites. I really like it a lot.